Welcome. The problem that we're going to next do is a variant of the problem we learned previously. You need to know nearly everything you learned in the previous problem. We're going to add an extra component to it. And that's the best way to learn chemistry, is to learn something and add one component at a time to make the problem more and more complex. All right, so we're going to take nearly all of the knowledge you learned from previous problem and add an extra component to solve this problem. All right, now if you read the question, it's asking, determine how many oxygen atoms, okay, are there in 3.5 grams of this compound. Now here's how you draw the problem visually. Okay, you're given grams and you have to go to not just the total number of atoms in the molecule, you're specifically asked to find the number of oxygen atoms. So remember I said you have these two conversions, and I'm going to actually show you how to use your scientific calculator to solve this problem. Okay, now if you're using a cell phone, then you have to come and ask me how I use it, because I cannot sit and make videos for 20 different cell phone companies. It's just not going to work. But if you have an American scientific calculator, then this will work based on what I tell you. If you have a Japanese like Casio or Sony, then you can YouTube it, because I don't have a Casio or Sony with me, but I'm sure it is available on YouTube. All right, so what I'm going to show you is based off of any of the American calculators, scientific calculators like Texas Instruments. Okay, this would work. Even if you have a TI-30X, it still will work. It's exactly the same format. All right, now we're going from gram to a specific element atoms. Okay, you will see another problem where you would go from grams to the total number of atoms. If you're going from grams or moles to total number of atoms, then you use the top one. If you're going from grams or moles to a particular element number of atoms, then you use the bottom one. You see the numbers are exactly the same, but you would quickly see how you set it up will probably be slightly different. So anytime you want to go from grams to atoms, first you got to convert grams to moles using molar mass. You're going to convert grams and molar mass to moles, and then moles to atoms. That's the general structure. Okay, but before that, we have to figure out what is the molecular mass of this titanium 4 phosphide. Titanium 4 means titanium is 4 and it's plus, it's a metal. Phosphorus is 5, so 8 minus 5 is 3, and it's a non-metal, so it's negative. So we cross swap it, so we get Ti3P4. And we're going to calculate the molar mass of this. That's roughly about 3 times 48 plus 4 times, I believe phosphorus is 31, so 4 times 31. Again, I'm rounding off. You're welcome to use the actual numbers. It literally makes no sense to, I mean, it will make no difference, but it's up to you. I'm just rounding off. 268 grams over mole. Again, I'm being consistent with the way I'm writing my units. I did not take any shortcut methods. So let me use a different color here. So you always start with the given information, which is 3.5 grams. And that's usually at the very top of the first block, and put a 1. As I said, think about it visually first if you can. If not, you can try to memorize it, but I don't recommend it. You're starting with grams. You have to get rid of what you start with. Anytime you have grams at the top, by default, you have to use the molar mass. There's nothing else that would go in this column. So I'm going to switch back to my red. To get rid of grams, I got to put the molar mass at the bottom. So the 268 grams goes at the bottom, and the 1 mole goes at the top. Very good. So now let's get the green and strike this off. So we have now canceled grams, but we now have a new problem. We got to get rid of moles to go to number of oxygen atom, right? As I said, if you have gram or moles and you have to go to a specific element count, then you use the bottom one. And the conversion is 1 mole equals 6.023 e to the 23 molecule, right? So we don't want the mole, so the mole goes on the bottom, right? And the 6.023 e to the 23 goes on the top, right? I do the whole calculation in one go when I finish constructing the structure. Now this is molecule, mind you. This is a molecule, right? This Ti3P4 is one molecule. Actually, I should have said phosphorus atoms. Let's change this oxygen to phosphorus, okay? So I had some other compound in mind and I changed it at the last minute, okay? This is a single molecule, what I've just circled here. How many phosphorus atoms does it have? 4. So one molecule contains 4 phosphorus atoms. So let me change this to P. Okay. And then let's get a different color. So we get to cancel the molecules. So we're left with just atoms in the end. So, all right. This might sound a little bit hard for many of you because chances of you doing anything remotely close to this type of calculation is very rare if you've never been in a chemistry class before. I don't think this type of calculation happens anywhere else. So you have to think, it's all very important you start with this given information, okay? Once you start with this, if your gram is here, by default, you have to use the molar mass as the next logical step. There is nothing else in the world that you can use to make this happen, okay? But again, you have to make sure what you're trying to cancel always goes in the bottom. Whatever you're trying to move forward goes in the top, right? Now, as I said, if you're looking to calculate a specific element, then you would have to use the bottom conversion factor. If you're just trying to calculate the total number of all atoms, then you use the top one. I'll do another problem to demonstrate the top one. But for now, let's focus on how to use the scientific calculator. So here we go. Here's how a TI-83 looks like. So I'm going to enter 3.5. So 3.5 is the number. Sorry, 3.5. It's so much easier with my keys than using it on my laptop. Over 268. Okay, this is not difficult. Everybody can do that. Now we are going to multiply that by the Avogadro number. Okay, I'll write the name later. So you enter times 6 decimal 0 2 sorry 6 0 2 3, and to get the exponent you hit the second once and hit this comma with the double E once. So I hit the second and then the double E once and then enter 23, hit enter. Now multiply by 4 and hit enter. There we go. So 3.14 e to the 22. So 3.14 e to the 22 phosphorus atoms is what we have. Imagine, that's a lot of atoms, right? So this is right here known as the Avogadro's number, not avocado, Avogadro's. Okay. So I don't want to keep repeating this because it's going to only cause more confusion. Think about what the question is asking. If it's asking for the total number of atoms, you use the top conversion, which I'll do a problem. If you're asked to find a specific element count, then you use the bottom conversion. and I have shown you how to set it up. You see, I'll be able to cancel everything that I don't need. I only want to be left with what I need, which is the phosphorus number of atoms. So I'm going to pause the video right here, and I'll come back with explaining the total number of atoms count problem. All right, so stay tuned.